In this video, we're going to be turning this into this. Welcome to the core functionality section of the series. In this video, I'm going to be showing you how to implement a simple Python PDF splitter, which is the primary function of the application we've been building. First, we'll start by creating a test folder in the root of our workspace and copying in a sample PDF document. If you need one, you can download a template 3-page PDF using the link in the description. Make sure that the PDF document you use is named sample_document.pdf. Afterwards, create a core.py file in the project module we created earlier. The primary purpose of this file is to handle the splitting of PDFs by being passed two paths, one for a PDF file and another for an output directory. Before we start coding, make sure that you have your virtual environment selected in the bottom right as your default interpreter. This will make sure that the Python linter is working and can detect the modules we've installed. Moving on, we'll import the PDF reader and PDF writer classes from PyPDF, as well as the path class from pathlib. Next, we'll write up our function prototype, using type hinting so our editor can provide more meaningful code suggestions. Type hints also provide a good foundation for further performance optimization with Python once we reach the compilation stage. For now, we'll just write parse and move on to the code that executes when this file is run directly as a script. Name equals main is a boolean expression that only evaluates to true when the core.py file is being called directly, such as when you run python core.py. Inside this if statement, we first determine the absolute path of the directory this core.py file is located in, and then create separate variables defining the PDF and output paths relative to the current file's directory. We do this because sometimes the script may be called from a different working directory, using a call like this for example. When this is the case, our relative paths would automatically throw errors once received by the split PDF function, as the path will not exist. Note that this / syntax only works because we are using path objects from pathlib, and will likely cause errors if you use string objects alone. Finally, we call split PDF with our two paths. Now, we return to our split PDF function. In here, we have three things that we want to do. First, resolve paths into absolute paths. I know we did this earlier in the code below, but we need to do this again as we have no guarantee that the arguments passed will already be resolved when other functions call this method. Next, we need to validate our arguments, and this includes handling invalid file types being passed. And lastly, we need to process the PDF file. So let's begin by resolving our paths just like we did before. Next, we need to perform some checks to see whether the path arguments we received even exist, and if they do, whether they are the right type of file system object. We also open our PDF file, but we'll need to wrap this call in a try except block, as it's not unreasonable to expect users to try passing in an invalid file type. Note that this still allows PDFs with an incorrect file extension to be used, which is our expected behavior. We've also just stuck with raising errors, as currently they are sufficient for debugging, but later on, once we've built the GUI, we'll change these to pop-up windows with an error message. We then just need to calculate the number of characters in the length of the PDF file so that we can left pad our output files with zeros. For example, a PDF with 100 pages has 3 characters in its length. Left padding is useful so output files can be easily sorted by name. Lastly, we then enumerate our PDF page data so we also get index variable I as we iterate, and create a new PDF file for each individual page. This here is a Python f string, which allows us to use variables within a string. The stem attribute of a path provides the name of the file it points to without the file extension. Here we convert I+1 into a string and call zfill to left pad the number with zeros as necessary. Our core function is now complete, and we can run our code in one of 3 ways. First, you can open a terminal, navigate to the module directory, and call python core.py. Alternatively, we can do a quick run using the play button on the right side of the File tab menu. We can also add a breakpoint somewhere in our script by clicking to the left of a line number where a red circle will appear. We can then switch to the Run and Debug pane, where we'll click the upper drop-down, select the current file config we set up earlier in launch.json, and press Run. As you can see, we now have information on the current value of variables and can also test out specific expressions before they occur using the watch section. For example, we can test whether the out directory path variable exists by clicking the plus button and typing in outdirpath.exists. We can now see that this value is true as expected. While debugging, we can move on to the next line using the step over button, or we can traverse inside a function call using the step into button. If we want to resume normal execution until either the next breakpoint or the program exits, we can use the continue button. These are all extremely useful when debugging issues in our software. Regardless of how you run the file, you should now see 3 new PDF files in your test directory. And if you open them up, you'll find the page matching the file name index. We can now move on to building our application interface. If you enjoyed the video, consider subscribing so you don't miss out on future uploads. And if you're ready to start learning about how to build a modern Python UI, click the video on the left. Until next time.